Hello, and welcome to Meeting the Challenges of the Ohio Core, a series of 3 webcasts focused on the challenges facing Ohio's middle and high school mathematics programs and teachers as they prepare students to meet increased graduation requirements. My name is Ann Meixel, and I'm a consultant for mathematics projects at the Ohio Resource Center for Mathematics, Science, and Reading. This webcast series builds upon ORC's Mathematics, A Look at the OGT series by modeling professional discussion and providing teachers, curriculum specialists, and other leaders in mathematics education with resources and information to strengthen mathematics curriculum and instruction. Many educators and parents have wondered why students seem to struggle in mathematics during the middle school years. Data from national, state, and local measures often support the need to focus attention on identifying the topics and conditions that contribute to the challenges students have in learning mathematics in grades 5 through 8. Today we will engage in a discussion about mathematics teaching and learning. We will focus on curriculum and instruction issues that may contribute to a downturn in student performance beginning at grade 5 on the Ohio Achievement Tests. We will not provide any silver bullets or prescriptive how-to methods. There are no silver bullets or simple solutions. Our goal today is for you and your colleagues to have similar dialogue as you work together, reflect upon your data, and plan actions to strengthen your mathematics program. Recent legislative changes, called the Ohio Core, will soon require all students to earn 4 units of credit in high school mathematics, including Algebra 2 or its equivalent. The first class that must meet these increased requirements enters 9th grade in the fall of 2010. Bottom line, these increased graduation requirements mean that more students need to take more mathematics in high school, which in turn means all students need to be ready for high school level mathematics when they enter grade 9. Our panelists will share some specific insights and suggestions to address these issues. They are Anita Jones, a mathematics consultant with the Ohio Department of Education. Anita was a Dayton Public School middle school mathematics teacher for 20 years before joining the department. Dan Breyer, a professor of mathematics education at Bowling Green State University and an 8th grade math teacher at St. Rose School in Perrysburg, Ohio. He has been teaching mathematics for 28 years and is a former president of the Ohio Council of Teachers of Mathematics. And Steve Miller, the learning specialist responsible for K-12 mathematics with the Akron Public Schools. Steve's career in Akron has spanned 30 years and included teaching at all levels, elementary, junior, and senior high school. He has been Akron's mathematics coordinator for 7 years. Our panel is very knowledgeable about middle school mathematics, but more importantly, they have all thought deeply about the kind of curriculum and instruction that will assure that all students learn rigorous, important mathematics that prepares them to be successful in high school mathematics and beyond. Anita, Dan, and Steve, welcome.
Thank you for having us.
Looking at data from Ohio achievement tests, as well as how students answer specific questions, can help us identify curriculum and instructional challenges within the middle school program that need to be addressed. Let's first look at the statewide data for the Ohio achievement tests. This first graph shows the performance by grade level for each of the 4 years the achievement tests have been given. At first glance, it looks pretty good. However, we see that students begin experiencing difficulty on the achievement test at grade 5, and the percent of students who score proficient or higher in grades 6 through 8 has yet to rebound to the levels for grades 3 and 4. The second graph shows the performance for the March 2008 administration by the 3 major subgroups. This is even more evident when looking at the data for the subgroups, as the differences in performance show that for our African American and Hispanic students, that the same dip in performance occurs. We need to take action to close the performance gap so all students are learning the mathematics they need to be successful in school, in meeting the new graduation requirements, in the workplace, and their daily lives. So what happens in grade 5 that makes mathematics so difficult? Is it the test, the students, the curriculum? Anita, you work closely with the Achievement Test program at the department. What insights from looking at the statewide data can you share?
When we looked at the data, and we get this question quite often, especially about grade 5, we look at grades 3, 4, 6, and 7 also to see what's happening. And we noticed that in grade 5, we introduced new concepts such as ratio, integers, frequency tables. We also noticed that we're moving away from concrete evidence of students' understanding into more applications and more abstract. So the level changes. We're moving the rigor of what's expected of students.
Let's look at some release measurement items to see what this looks like across the grades. The first item is a grade 3 item from 2006.
We have question number 8. Rachel lines up beams on two sides of a rectangle. How many beams will Rachel need to go all the way around the rectangle? We can see that we have a visual here for the 3rd grade students. And also, they're almost told what to do. Find out how many beams are going all the way around. 80% of the 3rd graders on this particular test found the right answer. But if we look at answer B, 15% of the students did this, and this is a big misconception. They only see the beams that are actually there, not thinking that you have the same amount on opposite sides. So they failed to add the beams from the other side that are missing and only came up with 13. But that was a good indication of what students could do as far as measurement was concerned. So now we move to a grade 4 item that still asks about perimeter. This is question number 25 from the March 2006 administration. Randy made this shape with toothpicks, and you have a picture here, and it also tells you that each toothpick is 3 inches long. The question is, what is the perimeter of the shape in inches? Describe how you would find the length of the perimeter. This is a short answer 2-point question. 64% of the students scored the maximum 2 points. But we also had 23% of the students to score 1 point, which was an indication that they know how to find the perimeter. But this is a 2-step process here. They failed to apply that the toothpicks are 3 inches long. So this tells us the students have learned this concept very well. They need to move into more application.
Now let's look at a 5th grade item, also from 2006, that involves perimeter in a context. Joe is putting a low fence around all 4 sides of a rectangular flower bed. The flower bed is 4 feet wide and 6 feet long. Each section of fencing is 2 feet long. How many sections of fencing will Joe need? Only 26% of the students selected the correct answer of 10 sections. This item is similar to the grade 4 item, however, performance was very different. Steve, what do you think students did differently in grade 5?
You know, Ann, there's a really interesting second step to this problem. The student had to understand that each section of fence covered 2 feet of the perimeter. So it is interesting that even as we look at the 4th grade item, even if they didn't understand the conversion from 1 toothpick to 3 inches, if they counted the number of blocks on the side in the picture, they would arrive at the right answer. In this case, they would not, because they would be picking the wrong answer because they had to convert that with the 2 inches. So vocabulary might be an issue in the term sections.
Dan and Anita, what other difficulties might there have been?
If you look closely at the responses here, you notice that response C was 24 sections, and 40% of the students got that wrong. It was the most common incorrect answer. 24, as it turns out, is the area of that rectangle. And for a lot of students, they read the question and they see 4 feet by 6 feet, and they automatically just multiply 4 times 6 and get 24, the area. And an interesting thing about that is that in that grade level, 5th grade, a lot of emphasis is placed on teaching students how to find area of a square, area of a rectangle, and they're kind of used to doing that. And the word perimeter doesn't actually appear anywhere in that problem. So for a lot of students, they're thinking area, and they see the problem, they see the numbers 4 and 6, they simply multiply them together to get their answer.
Another thing I noticed about this problem is that even though some students might recognize the connection between fence and perimeter, they stop at the first step. They actually find the perimeter. And we see this a lot, that students get the first part and, oh, I have my answer, and move on, and not go to the second step in this problem.
As a former 7th grade math teacher, I'm always interested in how 7th graders do. Let's look at a 7th grade item from the 2008 test.
This item says, in a tabletop in the shape of a trapezoid is made up of a rectangle and 2 congruent right triangles. The bases of the trapezoid are 70 centimeters and 130 centimeters, and the height is 80 centimeters. What is the area of the tabletop? We can see that 40% of the 7th graders got that item correct, the correct answer being 8,000 square centimeters.
Dan, are you surprised by the performance considering students had access to a calculator during testing? What do you think it shows about student understanding?
Well, in some ways it is kind of surprising. The students are being asked to find the area of a trapezoid, and there is a formula for area of a trapezoid. You take 1/2 of the height times the sum of the bases, and they should have learned that in 7th grade. But on the other hand, you don't really have to know that formula to be able to get this problem correct. For example, the item itself tells you that the picture is made up of a rectangle and 2 triangles. If they know how to find the area of the rectangle by taking 70 times 80 and how to find the area of one of the triangles and double it and add all those together, they can get the total area. Or they could even take one of the triangles and kind of cut it off, flip it over, and put it on the other side, and it makes one big rectangle that is 80 by 100, and simply multiply those together. So the problem says that it's a trapezoid, but the student really doesn't even have to know the area of a trapezoid formula to be able to get the answer right.
Well, what kind of instructional strategies could be used to improve student understanding and performance?
It's really important that students have a hands-on feel for how to find the area of a region. So I would see in a classroom like this, the students should be taking, having, say, a paper representation of a trapezoid and be able to physically take a pair of scissors and cut one of the triangles off and flip it over to the other side and see what actually makes up that trapezoid. We see similar things. A lot of the websites now have manipulative visuals that they can access by using, say, a smart board or even on a computer screen, and the student can manipulate those shapes and recognize that when they're trying to find the area of a region, that region is oftentimes made up of other smaller shapes that they already know how to deal with if they know what they're looking at.
Anita and Steve, anything you would like to add?
Well, I'd like to talk about answer A, which is 240 square centimeters. And this is a result of a student who tried to memorize the formula, and as Dan said, would not have made this mistake if they'd had some understanding. So they knew they had 1/2 of the height, but instead of multiplying it times the sum of the 2 bases, they added the 2 bases to 1/2 of the height.
I also think it's very important for teachers to look carefully at the benchmarks and the grade level indicators so that they realize the level of complexity that students need to experience. In this case, the verbs and the descriptions in the indicators would tend to have teachers teach the way Dan described in allowing students to do hands-on understanding of a topic instead of just the procedures where they would make the mistake that Anita could allude to.
We see through these examples that students' understanding of perimeter and area does not appear to grow in the way we expect in the middle grades. Yet we know students study area and perimeter throughout the middle grades. We can find similar clusters of items for other topics in mathematics and also find similar performance patterns in areas of concern. Steve, what issues have you found as you've looked at your district's data?
And when we look at at our district, we realize that as we pay attention to the grade bands in mathematics being 3-4 and 5-7, that teachers in Akron that start the 5-7 grade band are in buildings that are K-5. And this causes the issue where the teachers do not have the opportunity to speak collaboratively with their peers of knowing where they are going and have the higher end of the mathematics that is being taught in that grade band. So that becomes an issue of being able to articulate and understand of where they are going.
One of the challenges of the Ohio Core is preparing more students to take more high school mathematics. Dan, you teach 8th grade students who enter a variety of high schools and mathematics courses in the fall. How do you do it?
I have sort of a special challenge because the students who are in my class may go to one of a couple of area public high schools. They may also go to one of a half dozen different parochial and private high schools. And depending on the school that they go to, they may be taking an Algebra 2, a geometry, or even an integrated course in high school, depending on the curriculum of that school. So my job is to prepare them for sort of any kind of high school track that they might get into next year. And I've decided over the years that the best way to address that is to get them to try to teach them to think mathematically. One of the important things that is both in the national and the state standards are the mathematical processes: problem solving, reasoning, communicating, connecting, representing. And if I can teach them how to become good problem solvers and to communicate about their answers and to be able to reason their way through a math problem, that will prepare them for high school regardless of what the curriculum is going to be. I think that teaching math is as much about teaching them to think mathematically as it is to teach them content-related skills.
Dr. Randall Charles, a former member of NCTM's Research Advisory Committee, defined a big idea as a statement of an idea that is central to the learning of mathematics, one that links numerous mathematical understandings into a coherent whole. What are some examples of big ideas that should be part of the middle school mathematics curriculum and instruction? Steve, would you like to start?
Sure. One I think that really needs to jump out is algebraic reasoning. Students really need to be able to find patterns and to be able to generalize as they look at numbers. I think Dan brings out a good point of looking at the mathematical processes, that it is not a quick fix to can you quickly get to the answer and move on, but really a deep understanding of those patterns and how they relate. It's a matter of working with those and doing and undoing of those numbers so that students can truly understand and develop those habits of thinking algebraically.
Anita?
Some other big ideas for middle grades are number theory, the connection between fractions, decimals, and percents, and the applications of those and when to use them appropriately. And then looking at more complex data representations, analyzing the data using the statistical measures and making sure that the interpretations and you're drawing conclusions from the data that you're presenting with.
Dan?
Hearing Steve's response makes me think about when I ask my methods students, undergraduates on campus, what it means to teach algebra. They will oftentimes say things like, well, that's where you learn how to factor a trinomial or you learn how to solve an equation. And that's true, but those are skills. They contribute to our overall manipulation and understanding of algebra, but they're only a small piece of that. And a big part of it is helping people to understand what it really means to develop this number sense, this algebraic reasoning over time, as opposed to just looking at it as a set of skills that children are learning in school.
Steve and Dan, what strategies have you used to increase the coherence in the curriculum and instruction in your school and buildings?
And in our district, we have looked very carefully at curriculum mapping, and we have developed pacing guides that ensure that all teachers have a map for how to get through all of their curriculum each year. It also ensures that students have an opportunity, even if they have to transfer within schools, that the subject matter is taught in the same sequence. We also have added common assessments, which allow us to make sure that we have equal teaching for all students. In order to help teachers with that, we have built units that will allow teachers to know what it is that students need to be able to do and be able to look at the big ideas, know common assessments that will allow have them get the ability to perform, and then have instructional strategies that allow teachers to have reliance not on the book but on best practice. And we've certainly utilized the resources of the Ohio Resource Center to aid us in that process.
Thanks, Steve. And Dan, what strategies have you tried?
In our school, we believe that dialogue across the grade levels is very important. So we have meetings with teachers from grades 3 through 8, and we meet routinely to talk about what's going on in our math classes. We talk about the curriculum, what some of those big ideas are that we're covering, what are some of our strengths and our weaknesses, and we look at a specific content piece and say, you know, this is something that we feel like we're sort of weak at. Where is it normally introduced, and what are we doing the next year, and what are we doing each year to reinforce that idea? We also get into a discussion about tools. For example, we'll talk about Geometry Sketchpad and say, you know, we want students to be doing things on Sketchpad. At what grade level are they first doing something with it? Where are they learning that? And what do they do the next year to reinforce the use of that tool? Same with graphing calculators and protractors or whatever. So the idea is to have that open conversation, to put the things on the table and start talking about what do we do well, what do we need to work on, and how can we work together as a 3-8 staff across the grade levels to develop the mathematics the best way that we can as a team.
Anita, the governor has recently called for the revision of the academic content standards. What strategy is ODE thinking about as part of the revision process to help districts and mathematics program become more coherent and focus on big ideas? Well,
when we first started looking towards the revision of the standards, we looked at the top performing countries in TIMSS, England, Finland, Japan, Hong Kong, Singapore, to see how they were doing as far as mathematics was concerned in the K-12 arena. And so we also looked at focal points as an approach to the big ideas, and along with these big ideas, supporting ideas. And the third thing we're looking at will be the articulation. Articulation will show teachers the progression of learning for certain concepts and ideas. And that we want to make sure that teachers know that in certain grades, instruction is to take place. But once that instruction ends and students have a complete understanding of it, we move into using what students have learned. And that if a teacher is working on, has already taught fractions, not to go back and teach it again when they move to a higher grade, but to make sure fractions are used in all applications with the students.
Now I'd like each of you to share one more practice or tip that teachers can use to strengthen their mathematics program. Steve, would you like to go first?
Sure. I've heard it said that if you want to know a topic, try and teach it to someone else. I think that is a skill that we need to apply into our classrooms and allow students to communicate their knowledge of mathematics topics, both written and oral, to other students and to their teachers. It will help teachers to understand what the students do and don't know. However, it requires teachers to develop their skills in questioning, so teachers have to become more askers of questions than deliverers of information.
Dan, anything to add?
Yeah, you know, in Japan, they say that the heart of teaching is in the lesson plan. And I think we have to be better about finding good, rich lessons that get our students answering good questions and also get a visual understanding, conceptual understanding of what's going on in the problems that they solve. I've found that a number of websites are really good for that. The Ohio Resource Center website is certainly a gold mine of good ideas. The NCTM Illuminations website is filled with hundreds of activities, applets, and teaching ideas that are very practical and hands-on. And the National Library of Virtual Manipulatives also features some wonderful visuals that students can do on a computer or a teacher can use on a smartboard to help students to visualize and make sense of the problems.
Well, one of the new things that's been added to the ORC website recently is mini collections that include released items, best practice and promising practice lessons and other resources linked to the benchmarks assessed on the grade 7 and 8 achievement tests. Anita, what are your final thoughts?
I think that administrators are an important part of this. They need to provide time for teachers to meet, to discuss the type of questions they need to ask of their students, and to also talk about the lessons and to make sure that they have the best practices for students to learn.
Today we looked at some issues and challenges for middle school mathematics programs. We encourage you to continue to look at data for your school and district from a variety of sources, achievement tests, local tests, and classroom assessments, to identify what grades and topics may be stumbling blocks for your students. We have also shared some strategies to engage teachers in cross-grade and building discussions designed to bring more coherence and focus to the middle school mathematics curriculum and instruction. Thank you for participating in this program and sharing your expertise with Ohio's educators.
You're welcome.
And thank you for your participation. We've only scratched the surface of these topics. Additional information and supporting materials can be found on the Mathematics Meeting the Challenges of the Ohio Core at the Ohio Resource Center website. If you would like to learn more about these topics, please contact ORC at web@ohioRC.org. ORC would be happy to work collaboratively with you to plan building and district-wide professional development programs. For the Ohio Resource Center, I'm Ann Meixel, wishing you success with all of your work in mathematics teaching and learning.